Exception handling is one of those things that no one really wants to talk about. We all want to think that we'll never have exceptions. So we have a tendency to write code that doesn't have any exception handling at all, perhaps, and then maybe we'll add it in later as we catch exceptions in our testing. Of course, this is not the intelligent approach and not the way things should be done. So we're going to give you some guidelines about exception handling just to kind of take some of the pain out of it. The first thing to know is that handling exceptions is expensive. Of course, it's really expensive if you don't handle them at all, but there are performance problems when you do handle them. So you, of course, would like to avoid creating exceptions. In order to avoid creating exceptions, we, of course, want to check our inputs before using. We want to avoid null object exceptions and out of index ranges and that sort of thing. And those, again, are fairly obvious, but it's something that you should think about. Another little bit less obvious thing is that we would like to return some sort of error instead of throwing an exception. And we'll take a look at some examples. First, our general form for handling exceptions. And I'm sure you've all seen this before. At least I really hope so. So we have our try block, and in that block we're going to have some code that might cause an exception. And we want to minimize, of course, the amount of code that we put in here. And we have our catch. In this case, I'm using the general type exception, and we'll talk about that in a little bit. And we catch that exception, and we handle it in some way. And then we have our finally block, which will be executed regardless of whether we make it through the try or if we have an exception that we catch. And the finally block is used to clean up any resources that we opened within the try. So let's talk about creating exceptions. What we would like to not do is this. We would like to not put some kind of statement that might cause an exception and essentially handle that, in air quotes, by putting in a try-catch block. And then, if I know that there's a possibility of this object being a null, saying, oh, I'll just catch a null reference exception. And this is a pretty simplistic example, but the theory remains, if I know there's a possibility of a particular type of exception, I should actually try to avoid having that exception happen. Because going into that catch block is a real performance hit. If you've ever stepped through the debugger and stepped through an exception, you can see the tremendous delay that the code has. So there's a lot of problems in actually causing exceptions that you could actually detect without throwing an exception in your code. So in this case, let's look at an alternative that I would recommend. Just simply check if the object is null. If it isn't null, well, then you can call it and do something on it. Otherwise, you handle the null reference. And in that else, it would be really, really good if you didn't just throw an exception. We'll talk about that next. So in this example, we're going to try to avoid throwing an exception. Now this method is a void method, despite the fact that it says getCustomer. So we have a getCustomer routine that returns nothing, and we pass in an int customer ID. And we're not happy if the customer is equal to a null after we've run this code that looks for the customer. And we're going to throw a new exception that says our customer is not found, and therefore our calling client has to handle the exception. We don't know why there's not a customer ID or an invalid customer ID. We're just going to throw it back out to the client and let them figure it out, and perhaps tell the user, oh, you entered in a bad ID or username. But we really don't want to throw an exception because, again, we have a performance issue here. So instead, we'd like to change this method to return a Boolean, perhaps, and check to see if that customer object is null. And if the customer object is null, return false. Otherwise, return true that we actually did find a customer. This is a very similar pattern to what Microsoft did with try-parse. In the old days, there was no try-parse, there was just parse. So you could do an int.parse and put in a string that was not an integer string, and it would throw an exception, and you'd have to handle the exception, which was obviously bad. A try-parse, as you know, returns a Boolean, indicating success or failure of the parsing operation, and it has an output parameter for the value of the output of the parse. So that's a much better pattern because it does not throw an exception, and you can handle anything if you have an invalid string input into that parse. So this is that same kind of idea where we're basically doing a try get customer. The basic idea is we want to minimize the amount of exceptions that our application ever throws. Try to catch specific exceptions instead of using that generic exception object. You'll have better performance, and you'll be able to provide more specific exception handling because you'll know exactly what that exception is. Also, don't rethrow the exception. There's a performance hit in doing so. It basically doubles the penalty that you're paying on catching an exception. If you really, really have to rethrow the exception for some reason, rethrow the same exception object. That way, you're not creating a new exception and you're not doubling up on that performance hit. The other reason is that if you create a new exception and then throw that, you'll lose all of the stack trace information that was in the originating exception. And that could be valuable information if you're logging the exception into some sort of log or event viewer. Try to surround as little code as possible in a try-catch. Number one, that means that there are very few lines of code in your application that you believe can even throw an exception, which may be a good thing, or slightly delusional, hard to say. But more importantly, it's a performance issue. The fewer lines of code that you have within a try-catch, the better your performance will be. Also, don't ignore exceptions without any notification or logging, basically having an empty catch block. You're essentially covering up something that's wrong. If there's an exception in your code, that means that something unexpected happened, and to just not do anything and not be aware of it is not necessarily good form. I know we've all done it before, myself included, but really, really think twice before you ever do that. It's also good to avoid putting exception handling inside of loops. And this is another one of those things that it does happen, and you do have to do it on occasion. But overall, you'd like to surround the loop in the try-catch, and you get better performance out of that. But there are times that you need to continue on with the loop and catch and just log the exception and keep on going with the other items within the loop. And that's understandable, but only do that when you really have to. So those are some guidelines for some exception handling. And do put some thought into your exception handling when you're creating your applications and your classes and your methods. It'll pay off for you in the long run and create a lot less headaches for you.